My dear students and parents, my educational videos are available to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subjects Maths, Physics, Chemistry, Zoology and Botany in English language. In this video, we are going to find the formula to electric potential at a point due to a point charge. We are taking a point O. In that point O, the plus Q charge is placed. There is also another point P. This point P is placed at a distance of small r from the charge plus Q. There are also 2 points A and B. Of these 2 points, the point A is placed at a distance of x from the plus Q charge. There are 4 points. At the point O, plus Q charge is placed. At the point P, the electric potential is to be found. At point A, electric field capital E is to be found. Between the points A and B, potential difference is to be found. Between the points A and B, potential difference is to be found. So that we have taken 4 points O, P, A and B. I think that it will be appropriate to the students to state 5 definitions and 5 formulae related to this derivation. What are they? The definition of electric force, the definition of electric field, the definition of potential difference, the definition of electric potential at a point, the definition of electric potential energy of 2-point charges. Now let us see these 5 definitions and their formulae. The first definition is electric force. The electric force is denoted by the letter capital F. The Coulomb's law states that the force of attraction or force of repulsion is directly proportional to the product of charges and inversely proportional to the square of the distance between them. The formula to the electric force is written as capital F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This 1 by 4 pi epsilon naught is the proportionality constant. This Q1 and Q2 is the product of the charges. That is, this electric force is directly proportional to the product of the charges. This R square is the square of the distance. So, the force, that is the electric force, is inversely proportional to the square of the distance, because R square has been written in the denominator. The unit of the electric force is Newton. Then we are going to state the definition of electric field capital E at a point. You are well aware that the definition of electric field, it is nothing but force experienced by a unit positive charge placed at that point. At the point A, the unit positive charge is placed. This plus Q charge will exert the force on the unit positive charge placed at A. Thereby, we will get the electric field at the point A. E equal to, capital E equal to 1 by 4 pi epsilon naught Q by R square. Then the third definition is the potential difference between 2 points. It is denoted by dV. It is the work done to move the unit positive charge from one point to another point against the electric force. Here work is done. For what purpose the work is done? The work is done to move the charge. How much charge is to be moved? 1 unit positive charge is to be moved. From where to where it is to be moved? It is to be moved from one point to another point. Why should we move the unit positive charge from one point to another point? Because there is a repulsive force. In that repulsive force, the unit positive charge is coming from A to B. We are going to do the work against this repulsive force so that the work is to be done. What is the formula for potential difference? The formula for the potential difference between 2 points A and B is dV equal to minus E dx. dV equal to minus E dx. We know that in physics, the formula for work done is force into displacement in the direction of the force. Why the minus sign has been inserted? The minus sign has been inserted because the work is done against the electric force. In this case, against the repulsive force, the work is done. That is, the work is done to move the unit positive charge from B to A. Next, we are going to state the definition for electric potential at a point due to a point charge. This electric potential formula we are going to derive. The electric potential is denoted by the letter capital V. It is also work done. It is also work done to move how much charge? To move unit positive charge from where to where the unit positive charge is to be moved. Here the unit positive charge is to be moved from infinity to a point at which we are going to find the electric potential. This work done is also against the electric force. So what is the difference between these two definitions? That is potential difference and the electric potential. In both the cases, the work is done. In both the cases, unit positive charge is moved. But here, in potential difference, the unit positive charge is moved from one point to another point. In the case of the potential, that is electric potential, the unit positive charge is moved not from one point to another point, but from infinity to that point, at which we are going to find the electric potential. This is the difference between the potential difference and potential. The formula for the electric potential at a point due to a point charge is capital V equal to 1 by 4 pi epsilon naught Q by R. The unit of the electric potential is volt. The unit of the electric potential difference is also volt. What is the unit of the electric field, capital E, at a point? The unit of the electric field, capital E, is Newton per coulomb or volt per meter. Newton per coulomb or volt per meter. These are the units of the electric field, capital E. Then coming to the last definition, electric potential energy of 2 point charges. The electric potential energy of 2-point charges are denoted by the letter capital U. Here also work done. Here also we have to move the charge. But in this case, we are not moving the unit positive charge. We are moving the total charge. From where to where we are moving this charge? From infinity to that point. What is the formula for electric potential energy? The formula for the electric potential energy of 2-point charges, capital U equal to 1 by 4 pi epsilon naught Q1 Q2 by R. What difference we have observed in these 5 formulae? In the case of the force, whether it may be electric force or it may be electric field, in the denominator the R square has come. In the denominator R square has come in the case of the force. That is in the case of the electric force and also in the case of the electric field. See the denominator, here there is R square, here also there is R square. In the case of the electric potential and electric potential energy, in the denominator the R square is not written, the R is written. Moreover, we can also understand one thing, that is in the case of 2 charges, if 2 charges is considered, in the numerator Q1 Q2 has come. Here also 2 charges has come, that is in the case of electric force. In the case of electric potential energy also 2-point charges has come, so that in the numerator Q1 Q2 has been written. But in the case of the electric field, in the case of the electric potential, we are considering that is we are finding the electric field at a point. In the case of the electric potential also, we are finding the electric potential at a point, so that only one charge has come. And say these are the differences between these formulae and these definitions. If this video and all other videos in maths, physics, chemistry, zoology and botany taken by me is most beneficial to the students, they can share this video with the other students and friends, relatives and all other persons known to them. Moreover, they can also subscribe. We are going to derive the formula for the potential at a point due to a point charge. First of all, we are writing the formula for potential difference between the points A and B. As we have already discussed, the formula for the potential difference between the 2 points is dV equal to minus E dx. The negative sign indicates work is done against the electric force. What is the formula? We discussed in the electric field, capital E equal to 1 by 4 pi epsilon naught Q by R square. So we are going to write that formula, that is the formula for electric field, capital E equal to 1 by 4 pi epsilon naught Q by X square. In the original formula, it is written in the denominator R, but here we are writing X in the denominator. Why? This R represents the distance between the charge, whether it may be positive charge or it may be negative charge, from the charge to the point at which we are going to find the electric field. At which we are going to find the electric field. So here, in this case, the distance between the plus q charge and the point A, at which we are going to write the formula for electric field is small x, so that we are writing small x in the denominator. Students should note one thing: the letter R or X is immaterial. For what purpose the small letter R or the small letter X has been written, that is important. This R or X represents the distance between the charge and the point at which we are going to find the electric field. What is electric field? Electric field is nothing but force experienced by the unit positive charge. In the place of E, we are substituting 1 by 4 pi epsilon naught q by x square. Thereby, we are getting the equation for dV as minus 1 by 4 pi epsilon naught q by x square dx. From this equation dV, the next step is we are going to find the potential at a point. So how can we find the potential at a point from the equation of dV? dV is the potential difference, that is difference in potential. So if we want the potential V from dV, we can get by integrating the equation dV. If we integrate the equation dV, we will get the equation for capital V, that is electric potential at a point. For that purpose, the equation V is written as integral infinity, that is lower limit, to R, that is upper limit, minus 1 by 4 pi epsilon naught q by x square dx. What is the duty of this dx? Duty of this dx, that is the function of this dx, is to identify the variable which is to be integrated. Since the dx has come, the variable x is to be integrated. Suppose in this place y has come, the variable y is to be integrated. In this place, if dt has come, the variable t is to be integrated. But in this case, since dx has come, we have to integrate the variable x. My dear students and parents, if this video is most beneficial to you, you can share this video and you can also subscribe my channel. In order to make the students to understand the concept of integration, I have explained the integration concept in 10 steps. In the first step, it is written that the potential V equal to integral infinity to R. Infinity is the lower limit, R is the upper limit, minus 1 by 4 pi epsilon naught q by x square dx. This is the first step. In the next step, I am going to say an important thing. We have to integrate only the variable. So all other data other than variable should be taken before the integration sign, so that minus q by 4 pi epsilon naught has been taken before the integration sign. the 1 by x square expression is placed after the integration sign. So this is the second step. So the potential V equal to minus Q by 4 pi epsilon naught integral infinity to R 1 by x square dx. We are knowing the formula for integration, that is to integrate the variable with power n. What is that formula? Integral x to the power n dx equal to x to the power n plus 1 by n plus 1 plus c n not equal to minus 1. It means that the number 1 should be added with the power n, and after adding number 1 with the power, the result obtained is to be placed in the denominator also. Here also n plus 1 in the power, in the denominator also n plus 1. N not equal to minus 1. If n becomes minus 1, minus 1 plus 1 will become 0. Any data divided by 0 will become infinity, so that n not equal to minus 1. Here in our case, on seeing this equation, the variable x with power 2 has been placed in the denominator. In the formula, we are having x to the power n, not 1 by x to the power n. So our next duty is to bring the x square to the numerator. If we bring the x square to the numerator, it will become as x to the power minus 2. So as a third step, we are getting the equation for potential V equal to minus Q by 4 pi epsilon naught integral infinity to R x to the power minus 2 dx. We are going to add number 1 with this power minus 2. Then after adding 1 with the power minus 2, we will get minus 2 plus 1. That result, that is minus 2 plus 1, should also be written in the denominator. You can ask one question here. Sir, what happens to the integration sign? What happens to the dx? The integration sign will disappear. We need not write the integration sign after making the integration. So the integration sign will not come. Moreover, the dx, the duty of the dx is also over. So I am writing the square bracket, and I am writing the lower limit and the upper limit. We are not applying the lower limit and the upper limit so far. After applying the lower limit and the upper limit, that will also disappear. So in the fourth step, potential V equal to minus Q by 4 pi epsilon naught x to the power minus 2 plus 1 by minus 2 plus 1. If we add the minus 2 plus 1, we will get minus 1. In the denominator also we will get minus 1. That step has been written as the step 5. Hence the step 5, potential V equal to minus Q by 4 pi epsilon naught x to the power minus 1 by minus 1, lower limit infinity, upper limit R. Then on seeing this, we can understand that in this equation there is minus sign. In the denominator also there is minus sign. So can we multiply this minus and minus? If we multiply minus into minus, we will get plus. So the next step, that is the sixth step, has become as potential V equal to Q by 4 pi epsilon naught, because we need not write the minus sign. Square bracket x to the power minus 1, lower limit infinity, upper limit r. Then next step is we have to apply the upper limit and the lower limit. First of all, we should apply the upper limit. If we apply the upper limit, we will get the one value, that is upper limit value. Then we will apply the lower limit and getting the lower limit value. The lower limit value should be subtracted from the upper limit value. So the seventh step is applying the upper and the lower limits. Hence, we are getting the equation for potential V equal to Q by 4 pi epsilon naught r to the power minus 1. This upper limit and the lower limit should be applied in the place of the variable x. In this case, variable x. In other cases, the variable may be anything. It may be y, it may be t, any variable. So in this case, we are applying the upper limit in the place of the variable x, so that we are getting r to the power minus 1 minus the upper limit value minus the lower limit value. As I have already stated, the lower limit value should be subtracted from the upper limit value. Now the equation for potential has become as V equal to Q by 4 pi epsilon naught r to the power minus 1 minus infinity to the power minus 1. This is the seventh step. We are going to write the r to the power minus 1 as 1 by r and infinity to the power minus 1 as 1 by infinity. So in the eighth step, the potential V equal to Q by 4 pi epsilon naught 1 by r minus 1 by infinity. We know that 1 by infinity is equal to 0. We also know that any data divided by 0 is infinity. We know that any data divided by 0 is infinity. So 1 by infinity is equal to 0. That is, any data divided by infinity equal to 0. Why? If we bring this denominator 0 to the right side and bring the infinity to the left side, we will get 1 by infinity equal to 0. So we are going to write 1 by infinity as 0 in the ninth step. As a result, we have got the ninth step as potential V equal to Q by 4 pi epsilon naught 1 by r minus 0. The final step is, if we write the constant separately, we will get the equation for the potential as V equal to 1 by 4 pi epsilon naught Q by r. My dear students, if you like this video, that is, if this video is most beneficial to you, you share this video with your friends, relatives and all other persons known to you, and also subscribe this video.